Good morning, everyone. Mr. AK here. Happy Monday. This is what, 3 weeks left, so keep up with it. You're almost there. Today we're going to be talking about something called the angle of depression and angle of elevation, which is going to relate to our trig triangles that we just recently did. So let me go ahead and share this PDF here. So looking at it, it's going to have our angle of depression and elevation are going to have to do with right triangles. So I'm going to be talking a lot about this picture over here to the left, over here. So first, the angle of elevation, that's right here, this 38. That's called our angle of elevation. So this is someone looking up at a hot air balloon. So the angle of elevation is the angle between a horizontal line and the line of sight so the person looking up, where the angle is above that horizontal line. So you see our angle here is above the horizontal line and below the line of sight. That's our angle of elevation. The angle of depression is also between a horizontal line. I'm not going to write the whole thing. The line of sight where the angle is below the horizontal line. So our angle of depression is right here. So there's that horizontal line, so the line of sight of whoever's in the hot air balloon is down this way. And the horizontal line going out from the hot air balloon, the angle of depression is made in between those two, and it's below the horizontal line. So if you're looking at this picture, one thing we notice, the two horizontal lines are parallel to each other. So the angle of elevation and depression are, if you're looking at these parallel lines, well, they're congruent because these angles are alternate interior angles. So if you're ever doing problems, the angle of elevation and depression should be the same. Just like right here, they're both 38. They should be congruent because they're alternate interior angles. Sometimes students they're also in two different triangles. So if you draw a vertical line right here or right here, we've got right triangles, which is why our right triangle trigonometry is going to be super important. A right triangle, singular. So a right triangle is formed. Now the angle of depression, angle of elevation are in two different triangles, right? The angle of elevation is made in this triangle. Angle of depression is in this triangle. Students often mess up the angle of depression and call it right here. But not only is that in the same triangle as the angle of elevation, so you know it should not be the angle of depression, but it's also not going to be congruent unless it's a 45, 45, 90. So let's look at another picture and practice describing them. So angle 1, as it relates to this situation, the peak of the mountain up here, or looking down to the cabin here, we're going to call angle 1. So this is from the perspective of the peak of the mountain. That's where the horizontal line is. So this would be our right triangle made. And angle 1 would be the angle or an angle of depression. Whereas angle 2 is from the person looking up to the peak of the mountain, making this triangle. Angle 2 would be an angle of elevation. All right, angle 3. So now 3 and 4 having to do with looking down at this cabin. 3 is an angle of depression. And you might have guessed it, that makes angle 4 an angle of elevation. Now, if they had asked us about, let's say, this angle and made this angle 5, we'd say that's nothing. And we don't, we can still use right triangle trigonometry or, our triangle sum formula or conjecture to find that angle, but it doesn't actually mean anything. So let's do a couple practice problems here. I'm gonna let's see, I'm going to save the palm tree one, I think, for your classwork. And a couple of those. So maybe let's do this sonar and the heavy cruiser one, and then I'm going to do some ones where you have to draw yourself. So the sonar of a Navy cruiser detects a submarine that is 4,000 feet from the cruiser. So if we, let's say, do this, this is 4,000. The angle between the water line, so that's our horizontal line, and the submarine is 34. How deep is the submarine? Well, that's going to be talking about this height here, or it's kind of hard to see. So I'm going to redraw a triangle here. So let's say this is our right triangle because they're talking about an angle of depression here between the water line and the cruiser. We've got our hypotenuse of 4,000. That's the distance between them. And they want the depth, or right here. So if we look at this, we're trying to find D, we're trying to find that missing side to find that depth. So we have the opposite of the angle and the hypotenuse. So we're going to use sine of 34 equals opposite, which is D, over our hypotenuse of 4,000. So hopefully you practiced this plenty last week, but take your sine of 34, multiply it by 4,000 because that's solving for D, and then we're going to get about 2,237 feet deep. That's what D is. Okay. A ladder leans against a house, and the base of the ladder is 5 feet from the base of the house. There we go. 5 feet. And that's inches. Erase that. And then what is the angle formed by the ladder in the ground right here? Well, here they're talking about an angle of elevation. The ground is our horizontal line. The line of sight is looking up the ladder. So we're looking for this angle. It's a 20-foot ladder, so we know that this is 20 feet. So right now we're using our solving for the angles. We're trying to find that angle of elevation. Angle, so we're going to say this is the adjacent, the 5 feet, and this is the hypotenuse. So we're going to need the cosine for angle of elevation, so I'll call it E, equals adjacent over hypotenuse. So then we're going to get the cosine of E equals 1/4. Now, to solve for the angle, remember, you have to do the inverse cosine of 1/4 to get E. So I'll type in my inverse cosine of 1/4, or 0.25, because that's what 5/20 is. And in degrees, that makes the E equal to 75.5 degrees, about. Oops, that was an erase. Hey, my stylus has a cool erase button. All right, now let's do these three where you have to draw yourself. So, skateboard ramp at a park has an inclination of 54 degrees. Okay, so let's draw a ramp. Inclined at 54 degrees, and its base is 12 feet long. What is the length of the ramp? That's going to be our hypotenuse, and it's at a 54 degrees here. Incline. So the angle of elevation, they're talking about inclination, that's the elevation. We have adjacent here and hypotenuse, so we'll say the cosine of 54 equals adjacent, which is 12 feet over hypotenuse. And we're going to have to solve for h. This is one of those where you have to multiply both sides by h and then divide by cosines of 54. So h equals 12 over cosine of 54. And so we got 12 divided by cosine of 54 degrees. And we get h is about 20.4 feet. All right, let's do B here. You are 200 yards from a river here. And you're standing 200 yards from it. Rather than walking directly to the river, you walk 400 yards along a straight path. And what is the angle between this path and the river's edge? So the river's edge is right here. This is the path. They're asking about this angle. So it's actually not really an angle of depression or elevation, right? This would be our angle of depression based on how I drew it. So maybe I could redraw it and it would work for one of them. So if we just redraw it real quick. Let's say you're right here and you're 200 yards from the river, but you walk to this 400. It's still gonna be the same thing because they're still looking for this angle. So it's not either of the angles, but we can still figure it out, right? This angle is, so let's just call it angle A. This angle is, we've got the opposite and the hypotenuse. So we've got the sine of A equals 200 over 400, opposite over hypotenuse. We're gonna have to do the inverse sine here. And you're gonna get A equals 30 degrees. All right, a water tower is located, so a big old water tower. Bet you're really laughing at my drawings in this one. Is located 325 feet from a building. From a window in the building, it is observed that the angle of elevation to the top of the tower, that's not quite the top, but you get the idea, is 39 degrees. So here's the tricky part. This is 39. The angle of elevation has to be horizontal to the line of sight. So really this is also going to be 325. And the angle of depression from the bottom to the bottom of the tower is 25. So this is 25. How tall is the tower? So we have to find both of these distances. So we've got the top triangle, let's say, so I'm going to redraw the triangles. Think back to our older units, I always said redraw them. We got 39 and 325 with this first height. And then we've got another triangle with height 2, that is 325 right here, and 25. So both of them are, let's see, we're going to use tangent because we have opposite, and we have the adjacent in both of them, but we're looking for the opposite. So I'm going to take the tangent of 39, and that equals, I ran out of room. (39) equals opposite H1 over adjacent. And this will be the same thing. Tangent of 25 equals our second height over 325. So type in your tangent of 39 and multiply that by 325 to solve for the first h. So our h1 is 263 about feet, and then do the tangent of 25, multiply that by 325, and our h2 is 100 and, let's do 152 if we're rounding to the nearest whole number. So the total height of the tower is, add them together, 415 feet. All right, so we're just using these angle of elevation and depression, these words that they describe, to draw pictures, more real life scenarios, to find different sides of our triangle or an angle in the triangle. So if you have any questions, please don't hesitate to send us an email or set up a meeting with us so we can answer your questions. And have a great Monday and a great week.